Hello guys, welcome back to my channel. My name is Deepak. I'm studying in Sri Venkateswara College of Engineering. My USN is 1VE21IS016. Today we are going to discuss about introduction to OTEC, Ocean Thermal Energy Conversion and its stations. Let's overview about the topic of ocean thermal energy and its conversion. Ocean thermal energy conversion systems harness the temperature and difference between the warm surface water and cold deep ocean water to generate electricity. The process to heat engine to convert the thermal energy into mechanical power, which then drives an electrical generator. OTEC, Ocean Thermal Energy electrical conversion stations can be either closed cycle using a working fluid like ammonia or open cycle using the ocean water directly. Overview of the OTEC technology. The ocean thermal electrical conversion system utilizes the temperature difference between the warm surface water and the cold deep ocean water to generate electricity. Warm surface water is pumped into a heat exchanger where it vaporizes a working fluid with a low boiling point like ammonia or propane. Expanding vapor then drives a turbine generating electricity. The cooled vapor is then condensed by the cold deep water and the cycle repeats. Global distribution of ocean thermal electrical conversion stations are currently concentrated in tropical and subtropical regions where the ocean temperature is differential is optimal. The major ocean thermal electrical conversion projects and pilot plants have been established in countries like Japan, China, India, the United States, and several highland stations in the Pacific and Caribbean oceans. Advantages of ocean thermal energy conversion power generation. The renewable and sustainable, reliable and constant, and environmentally friendly. The OTEC taps into the vast, inexhaustible thermal energy of an ocean, making it a renewable and sustainable source of electricity. Unlike intermittent renewable sources like solar and wind, OTEC provides a steady and reliable power supply due to the stable ocean temperature. OTEC systems have a low carbon footprint and do not generate greenhouse gas emissions making them a clean, eco-friendly energy solution. Challenges and limitations of OTEC. High capital cost. It results in high capital cost, technical complexity, and environmental concerns. OTEC stations require significant upfront investment for the construction of large-scale infrastructure, including deep water pipes and heat exchange systems. The technology involves intricate engineering challenges such as maintaining the delicate thermal gradient and mitigating biofueling and corrosion issues in the ocean environment. It may have potential environmental impacts such as disrupting local marine ecosystems and alternating ocean currents and temperature profiles. Harness of ocean thermal energy. Its stands OTEC stations leverage the temperature difference between warm surface water and the cold deep ocean water to generate clean. This will make the difference between cold water and the hot water. The renewable electricity, and it produces a renewable electricity. This facilitates use a heat challenge systems to drive turbines and produce a reliable power supply. all while minimizing the environment impact. Challenges and limitations of OTEC: high operational cost, technical complexity, site-specific limitations, environmental impacts. It requires extensive infrastructure, including deep sea pipelines, specialized heat exchangers, drive up initial capital, and maintenance. Designing and operating OTEC plants pose significant technical challenges such as managing corrosion, biofueling, and efficient transfer of thermal energy. Like site-specific limitations, OTEC will variability is heavily dependent on the availability of the suitable ocean temperature differential restricting deployment of tropical and subtropical regions. OTEC plants can disrupt marine ecosystems by altering ocean currents and temperature, potentially impacting local flora and fauna. Emerging OTEC projects and developments. Pilot plants and proliferate. New OTC pilot plants are springing up in tropical regions, testing innovative designs and technological to improve efficiency and cost effectiveness. Hybrid OTEC systems, combining OTEC systems with other renewable technologies like solar and wind is an emerging trend, leveraging synergies for greater energy impact. Floating OTEC platforms. Offshore floating OTEC plants are being explored to overcome site-specific limitations and enable deployment in deeper ocean waters. Environmental impact of OTEC ocean thermal energy conversion stations. Ecosystem description, biodiversity protection, discharge management, collaborative effects. OTEC plants can alter local marine ecosystems by changing ocean currents, temperature, and nutrient levels, potentially impacting sensitive coral and other coastal habits. Biodiversity protection, careful environmental assessment, and mitigation strategies are crucial to minimize the impact of OTEC stations on the delicate ocean systems and ocean ecosystems and protect local marine biodiversity. Discharge management, the cold, nutrient rich discharge from OTEC plants can be used to support local aquaculture and mariculture efforts, but must be carefully monitored to prevent disrupting the knowledge of natural resources. Collaborative effects, partnerships between the operators, environmental agencies, and local communities are essential to ensure the suitable, sustainable development of OTEC stations along with the long term. This is economic flexibility funding for ocean thermal energy. Achieving the economic viability is a key challenge for widespread OTC adaptation. The high front capital cost and capital complex infrastructure requirement pose significant barriers to commercial scale OTEC deployment. Here is the bar chart to represent the how OTC funds are released. Means ocean current thermal energy, how the funds are invested. The government investment is around up to 150, and here the private investment is around 250 or 240, yeah, at that range. And it's the multilateral funds. It is around 100. Yeah. The diverse funding models are combining the government innovative and private sector investors and development banking financing are the crucial to improve the economic feasibility of ODEC projects and drive further technological advancements. Regularity frameworks and policies for ODEC, permitting and licensing OTEC projects require permitting, and licensing process to um, ensure the compliance with environmental regulations, secure grid interconnection, and obtain necessary approvals from local, national, and international cooperation. Effective OTC deployment often requires cross-border collaborations and harmonized policies as the thermal gradients and optimal deployment sites may span multiple jurisdictions. Incentives and subsidies. Government incentives such as tax credits fixed in traffics and research and development funding can help upset the high infront cost and drive the commercialization of OTEC technology. The robust environmental impact assessment and monitoring protocols are crucial to mitigate the potential disrupts of OTEC plants may cause to the sensitive marine ecosystem and acquire long-term sustainability. Future outlook and potential OTEC worldwide. Technological advancement, renewable energy migration, emerging markets and applications support these policies and regulations. Continued research and technological advancement. Continued research and development will drive improvements in OTC system efficiency, cost effectiveness, reliability, expanding its global deployment potential. Renewable energy integration, integrating OTC with other renewable energy sources like offshore and wind and solar can create hybrid systems that leverage synergies and provide more reliable round-the-clock power. Behind electricity generation, OTC technology is being explored for novel applications such as seawater desalination, aquaculture, and distinct cooling, branding, broadening, and commercial visibility. Supportive policies and regulations, strengthening regulatory frameworks, functioning financial incentives, and international cooperation will be the crucial to overcome the high infrared cost like drive large OTC deployments. Thank you.